So, Blu-ray disc is 12 centimeters in diameter. So, radius of 6. I just changed that for it again. And the Blu-ray player drive is able to rotate 10,000 revolutions per minute. And again, I think that's a pretty realistic number. If you have a Blu-ray player at home, I'm sure you could look at its manual or Google search its model number. And I would not be at all surprised if it really does spin that fast. And so we want to know how many radians is that, not how many rotations is that per minute, but how many radians is that per second in part A. Okay, well they gave me angular speed, and in part A they want angular speed. So the whole point of this part A is just to change the units. Change them from revolutions per minute to what they want, radians per second. Okay, so the more familiar one, how do you change minutes to seconds? I'm multiplying by 60. I'm dividing by 60. 1 minute is the same as 60 seconds. You need your seconds to be in the denominator. Or you need your minutes to be in the numerator, really. Okay, so there's revolutions per second, which is close to radians per second, but not quite the same thing. So the new conversion here is we can say 1 revolution, which I know needs to go in my denominator. That's what would make the revolution units cancel out. It's the same thing as 2 pi radians. Now I know I'm ready to multiply across the top and multiply across the bottom because I've got only radians in my numerator and only seconds in my denominator. And that's what it asks for. So now I would let my calculator tell me what 10,000 times 1 times 2 pi. Does anyone know if they left the answer in terms of pi? I know this is kind of a hard question, but they did? Okay. So I won't multiply in pi. This would be 20,000 pi would be my numerator. My denominators would be 60. If I reduce my fraction there, that is 1,005 radian per second. Or you can multiply in pi if they want to. So again, part A, they gave you angular speed, they want angular speed. Just convert to units. Part B, if we were to take a particle on each edge of the disk, the very outmost part, we can figure out how much, if we straighten that out, how fast that single point's actually moving. So how fast it's turning, but if we straighten it out, how fast it's going in a straight line. So that's what they are asking for, linear speed. And the only way for you to relate linear speed is that it is angular speed times r. So if you're having trouble getting started, that should be your start. Write the formula. Write what angular speed is. I guess I could use this or this. Whichever one you think is going to be better. I honestly don't know. You want to keep up with the units. And I need to multiply that by r. So by far the biggest mistake when you guys are working on the book assignment, a little bit in this class and a little bit in all my other classes, you guys get so wrapped up in worrying about it being meters per second that you're not even multiplying it by r. Make one step just be, here's my angular speed times my radius. Worry about the units right before we end. Don't multiply by r. Some of the questions I have are like, how do you turn radians into meters? And you can't. Those are 2 different types of units. You can turn centimeters into meters, but if you don't know how to multiply by r, you're not going to know that you have centimeters to work with. Okay, so radians are a blank unit, so I can ignore that. So right now, if I multiplied it across the top, I would have centimeters. If I multiply it across the bottom, I would have seconds. And it doesn't want that, it wants meters per second. So I need to get rid of the centimeters, and I want it to become meters. So how many centimeters is equal to how many meters? 100 to 1. Alright, so now I've got my units ready to go, so now I'm ready to multiply. Some people were saying that part A was left in terms of pi, so now assume part B is left in terms of pi. 1,000 times 6 times pi would be 6,000 pi. Over 3 times 1 times 100, which would be 300. And that reduces to 20 pi meters per second. And that's the great exact answer. That's probably what I would do if it doesn't say, like this one doesn't say. But if we're trying to wrap our head around, is that fast or not? Maybe we would actually multiply these. So that single point is traveling 62 meters per second. So you guys know how long a meter stick is, right? So 62 of those every single second that one spot is traveling these great distances on. So they have to spin those discs very, very fast. So that gives you an idea of how fast the fast is spinning. I mean, also saying it spins 10,000 times in a minute. Sounds kind of fast, but actually thinking of a spot straightening out that distance, that many meter sticks in 1 second,